get scenarios there that come to play. And then the other thing is trying to figure out the human factor of it. Human factor in two ways. One is, especially in the sports arena, as you talk about this, and HR analytics in general that companies are, greatly getting into. How do you determine success? How do you predict success of any given hire or group of hires, a team of people working together? How do you predict the success of that team? And this could be a team of engineers, it could be a team of scientists in a pharmaceutical company. What's the probability that research in the direction of a particular drug will be successful? Of course, companies are looking into that because that is the difference between being a profitable company and a company losing money. So, so those human factors. So how do you incorporate that into your analysis? And also the flip side, there's two kind of things, debate and discussion going on in this arena, which is you can never quite fully quantify life, right? Can't put all that stuff into numbers and say, this is the way it's going to be based on a computer chugged it out. You can do procedural things, such as IBM did with Big Blue and Gary Kasparov with chess, right? You can say, okay, a computer can think out how many steps ahead. A human person, can they think out 30 steps ahead in a chess game? Can they think out 100 steps? Can a computer look through 150 steps out and compare all the scenarios that could happen and then come up with a decision? You can do some of that, right? But there's ultimately, especially if you think of electronic medical records and a doctor, ultimately you need some human decision making. And so you use probability and statistics and analyzing data and all this information to help make better decisions, maybe not always make the decisions themselves. All right. Where else do you see probability and statistics? Of course, simulations. And, you talk about video games. You talk about war games. You talk about military. And this is one from Wiki I just pulled down. But under the covers of simulations is volumes and volumes of data and scenarios and information of things that have historically happened to then use that to predict what might happen in the future. So this means statistical information can be gleaned from such a model. Outcomes can be quoted in terms of probabilities and plans developed accordingly. So another decision support kind of thing. But what runs on it? So I'll leave you to read this fully. In engineering, just a few things, and we're actually going to have a guest speaker from Texas Instruments during the second week of our class. Dr. Joel Dobson, he'll be coming in. He's a quality engineer. That's his title, but he actually is like the go-to statistician at Texas Instruments. He'll talk about the kinds of studies that he gets pulled into, some of which are quality, some of which are marketing, some of which are, he's all over the map in terms of inside the company. So he'll give you a flavor of some of that. We also have the guest speaker coming in, someone who is currently probably one of the top scouts that the New York Yankees has. So he'll come in for a couple hours during that second week as well. You'll have the opportunity to ask him some questions about, if you're a sports fanatic, you'll be able to ask him some questions about how statistics and these kind of things. And it's a bit on the old school side, so it's going to be kind of hopefully an interesting discussion. So we have a number of different guest speakers who are going to be coming in. Those are a couple of examples. Again, what are my course objectives? Diverse technical backgrounds and objectives, interests. I know that some of you are science students, some are outside of engineering. A number of you are engineering students. I hope to be able to kind of, and this says involved in engineering decision making, but I hope to kind of, it's going to be a broad kind of discussion. Medical community, science community, maybe in the business community. So we'll go after that, but a balance of the theory and the application. So it is important you leave the course with a foundation so that as you go into continued studies, whatever they are, when somebody goes and talks about uses a term, standard deviation, sampling distribution, uses the things that we're going to talk about in next month, that you have a firm foundation in that, but also we'll spend some time on the application. It's a lot of material. I mean, there's a reason this is a semester course, and in fact, if I was the guru to decide curriculum, I would probably even split this course, and you would have a semester of probability and you'd have a semester of statistics, because I do feel as we get into an age of big data, it's important to have a firm foundation. But we will go through both of those during our 8 days together. It'll be, I've taught this will be the second time I'm teaching it. Students last year thought it was pretty reasonable. Thought it was a pretty fun way to do it, especially with the recordings and coming and working in small groups, solving problems for the most part, and listening to guest speakers and this kind of stuff. So we'll cover a lot of ground. The theory is really, some of it's hundreds of years old. Not really, in terms of the math of this, some of it hasn't changed at all. Some of it has progressed. But what's changing is the ability to gather data and do analysis on that data and apply all of this theory. And again, I'll make the comment, you're going to see lots and lots of formulas. You're going to see lots and lots of topics. And we're going to try and stay at that middle level, enough to give you the foundation, but not too deep to get you lost. Okay, so out on the blackboard in the syllabus folder, you will find a course outline to give you a sense of how fast and what pace we're going to be keeping, what the expectation is with regard to watching the recording sessions. And this is it that you'll find, and it's an Excel workbook where I've mapped out the different, for each day or group, a couple of days, the topics that we'll be covering. So the first day, I just want to kind of go through, do some introductions, and then cover the second chapter of your textbook, which is a pretty beefy chapter. Some students have seen some of these things, basic counting, permutations, combinations. If you remember doing any of that in high school, you're going to come back to it. Something called Bayes' theorem. We're going to go through some of those the first day. And then Tuesday, Wednesday, we'll go right through a whole slew of what's called discrete random variables. Discrete, of course, meaning 1, 2, 3, 4. What's the probability of a car accident at 6:35 and 75 on a Monday afternoon? What's the probability of 5 car accidents? Discrete, meaning that way. And then Thursday, we are going to have Dr. Shirlene Pearson coming, and we're going to be doing a full day of SPSS statistical software workshop. And this one, we'll talk about it on Monday when we meet up on the 7th, but kind of going through that, get you started on some software as well as the theory. Friday, we'll be continuing with the continuous random variables. So what's the probability? It's different than discrete, right? It's what's the probability that someone is 5.5 feet tall? Someone is what's the probability that somebody lives to 92.4, 5, 6, 7, 8, 9, whatever years old before they die? So those are getting into continuous distributions. That will finish the week on that. Monday we'll get into really what I'd call we'll switch from being probabilistically focused to statistical analysis focused, and that's what we'll go through the second week, those 3 days that we have together, along with the guest speakers trickled in, some discussion on some relevant topics such as data visualization and the visualization presenting statistical information. We'll have a bit about that. Let me get this back into viewing mode. Here we go. All right, textbooks. One is your core textbook. This is the Probability and Statistics for Scientists and Engineers. Can find it on Amazon. Got you the ISBN. Looking for the 9th edition. People will find the 8th edition. At this point, that's fairly old. I think it's a 2011 book, so you should be able to find some used ones or something online. Get a hold of that. You'll be needing this in class with you when you come, because we're going to actually be spending a lot of time when we're together solving problems out of that book. So it'd be better if you had a copy of it. Some people if you bring in the 8th edition or something like that, we might be able to do the mapping of, problem 4.63 and the new version in the 9th edition is 4.59 in the 8th edition. But if you can, get your hands on the 9th edition. And the other book I'd like to propose that you read is the Competing on Analytics, the New Science of Winning. And whether you're coming at this course from an engineering perspective, a science, a business, whatever perspective, I think this gives a nice overview of data, of probability and statistics, and of the environment that we're in with the kinds of questions people are asking, and from a corporate standpoint. So whether you're a pharmaceutical company or you are a civil engineering company, building the high five, whether you are a sports team or you are, a medical community, everybody's got the similar kinds of questions, different in what field they're in. But I think in terms of engineering and scientific work, this is a nice overview to give you the business aspect of it, but you'll see that the structure of how they do it is actually applicable in a lot of different ways. Okay, as my email previously indicated, lectures are pre-recorded. They're all posted on the Blackboard. You got the slides up there as well under the course documents. You'd find the corresponding slides. In each lecture, if you've had a chance to listen to them, I put up some problems that you could solve. Pause the lecture, solve a problem, make sure you got the concept. Because we haven't yet met, you may or may not want to give a try to those problems. It doesn't, either way. I will say when, if on Tuesday we say we're going to be covering a specific topic and you need to listen to the recording before that day, that's the time it's going to be critical for you to give a try to those problems so that you come to class ready to go, ready to solve problems. Tried to make them about 20. I think there's one that's like obscenely long, maybe an hour or something crazy. But for the most part, I tried to make them 20 minutes or less. So big thing, make sure, according to that outline that I just showed you, that you are watching those recordings before each class. So at this point, given it's December, if you are listening to this, watching it before class, January before class, the day before January class, your January 6th, whenever you're listening to this, the key thing is that you're going to need to watch those recordings before each class so that you're fresh, it's on your mind, and you're ready to go for problem solving. Assessment. You can have daily, you're going to have assignments that you're going to go home and solve. 1, 2, 3, 4, I don't know, a variety of different number of problems applicable to what you've just spent the day working on. 50% of your grade will be based on the results of that, on how well you do with those. I will assume those are independent work, that you are not, that it is truly just your work, and so I can get a reflection of how well you're tracking the material. The other piece are going to be some in-class exams. It's kind of funny because we are on such a brief schedule, and we also have things like the workshop and a guest speaker coming on Friday, that first Friday from IBM, and we'll go through the whole of the probability sweep. And then Monday morning, the 14th, the first thing you'll do is take an exam in class, and that'll be 15% of your grade. And then the last day of class on the 16th in the afternoon, you'll take another exam, and that'll be the other 15% of that grade. Next, 20% of your grade is going to be based on a team project. So Thursday, again, you're going to have the SPSS workshop, and on Monday, Tuesday, Wednesday, Friday Thursday will be the workshop. Friday we'll try and get the teams together, and then those 3 remaining days that we have the class, you'll get some time at the end of the day to work on your projects, but 20% of your grade will be based on what you do there. All right, so that's it. I just want to kind of kick the course off, give you an overview of it. Monday we'll get in, we'll have some introductions, question and answer. If you have any questions, you can email me or get in touch with Tammy at the EMIS office and beforehand. Otherwise, I'll see you on that Monday, January 7th. Best wishes for a wonderful break.